Let's go ahead and look at this final crash dump, which is a stop D1 or a driver IRQL not less or equal. So we'll go ahead and bring up the debugger and load the fourth demo. And off we go. We can see here that it was a D1 bug check. It's bringing it to our attention that it couldn't load symbols for elxstore.sys. That could be a clue right there. In fact, it says that the crash was probably caused by elxstore.sys. So we could go ahead and, of course, start with reading the online help for the particular D1 bug check to get us off and running. But we're going to go ahead and hit the bang analyze-v hyperlink, which will do the initial analysis. Let's go back and read a little bit about this crash. It says that a driver IRQ not less than or equal. An attempt was made to access a pageable or invalid address at an interrupt level that is too high. So we can see things like the IRQL, that's the interrupt request level, was 8 at the time. And we tried to touch memory location 7 Fox Echo, 7FE. And that was also the address which referenced that location. So something isn't quite right because those memory locations are too small of a number. What Windows will do is put up what's known as a guard page of zeros. So it tries to protect things like the very low addresses and the very high addresses. Because programmatically speaking, most coding errors result in a value of 0. So that's why Windows puts up a guard page to try and protect against access to those very low addresses. So as we read through the analyze-v, we can see information like the currently executing process. And we'll just scroll on a bit more. There was a trap frame. A trap frame essentially gives us context to a particular portion of the stack, and it shows us all the registers that were present at the time. And there, if we scrolled over to the far right, we would see the stack trace. And you can see it was just executing in that mshield.exe when it got interrupted. And then the elxstore driver started executing. It started executing at particular offsets like FC port, core deregister, state handler. Whatever that does, I don't know. All we know now is that that driver was executed and then it incurred a page fault. It tried to touch a memory location, namely this 7 Fox Echo, at an elevated IRQL, and you're not allowed to do that. Not only is it at an elevated IRQL, it was at a bogus address of 7FE. So we could do several things here. We can go ahead and show the thread that was executing at the time. So again, here we know it was an mshield.exe that was executing. And there's the stack over on the far right. We can just simply do the KB command to show an abbreviated version, or even just the K to show us a much more terse version of that stack. Now, there was that trap frame that we noticed, and what we're going to do is actually go ahead and hit that trap frame because that'll establish our context. It'll show us all the registers, the values that they were at the time of that call. And so what we'll do now is show that stack once again, just the very terse version. And what we can do is actually see what was executing at the time by doing the U command. That's the unassemble command. So I'm going to essentially do UB for unassemble backwards from that point to show me the instruction stream leading up to where we crashed. And as you can see, it was executing things like the move, then it executed a call, and then it executed another move, jump, a few more moves, and then ultimately it executed this call instruction. which the first thing it's going to do is try and push the return address on the stack. That's why we see this 7, 8, Fox, 5 Apple on the stack, because if we were to unassemble a bit more, there's the next address that follows right there. It would have been a move command had we come back from this call function. So what exactly was it doing? It was trying to call based on something indexed by R8 plus 178 hex. Well, because we issued the trap frame up here, we know what's in R8. It's this value right here. So what we're going to do here is identify what was in R8 at the time, plus 178, and we can use the dd command to do this. So we're going to take what was in R8, grab that value, and then we're going to add 178 hex to that. And we can see that there is the value that it was trying to locate, this 7FE. And that is indeed the bogus area of memory that we tried to execute. So something corrupted that area of memory. So a pretty good bet is that it was this ELX store driver, which is obviously by Emulex. But one thing to keep in consideration is that these store port various drivers out there like ELX store, they depend on another driver released by Microsoft called StorePort. So we want to take a look at that too. You want to make sure that you're running the latest version of StorePort and the latest version of this ELX store driver, because one can affect the other. So essentially what we've done here in this crash is we found out the stop code type, we looked at the stack, and we saw that the ELX store.sys driver was the only one present and doing business with this information. So we can safely conclude that we would want to make sure we have the latest and greatest ELX store driver available. And for that, we would either contact Emulex or the vendor whose machine is running this driver. So hopefully that gives you a good idea of how to go about tackling a stop D1 bug check.